Okay, so last section we're going to look at for this week is 8.1. We're only going to look at the first half of the section, so it's not even really a full section. And it's on what we call the law of sines. So the whole goal this week is, or for this lesson, is going to be to figure out how big the angles are and how big the sides are in a triangle. Now you might be saying, we already did that. We've already figured out how big sides are and how big angles are. But when we did it, you always had a right triangle. We're basically looking at the same idea again, except now you don't have a right angle. So when you don't have a right angle, then you also don't have a certain side in the triangle. What side is missing if there's no 90-degree angle? You don't have a what? Yep, hypotenuse. You don't have a hypotenuse. Well, the way I taught you guys to do this a couple chapters ago was sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, but you don't have a hypotenuse. So none of that is going to work here. So the way you solve a triangle when you don't have a right angle is one of two laws. There's the law of sines. There's also the law of cosines. Which law you use depends on what information I tell you. So the two kinds of triangles that you can have that are not right triangles fall under the category of what we call oblique. An oblique triangle is a general term for a triangle without a 90. More specifically, an acute is an oblique triangle where every angle is less than 90. Obtuse is an oblique triangle where you have one angle more than 90. Could you have two angles in a triangle more than 90? Why not?
Because all the angles in a triangle have 180.
Yeah. So you can only have at most one angle more than 180. Regardless of which actual triangle it is, I will tell you that none of my drawings are to scale. I pretty much draw everything like this. Okay, so my drawings are not to scale. What's important in the drawing is that you label things correctly. That's all that's important, not the scale. And here's going to be our diagram that we're going to use for every problem. Chris, when we label a triangle, what do we normally call the, what do we name the sides? Think of like, there's a theorem we use in geometry and you use these letters in it for the sides in a triangle. Yeah, in the Pythagorean Theorem, what is the name for each side?
A, B, C.
Yeah, what are A and B?
C is the hypotenuse.
Yeah, C is the hypotenuse. And
A, B could be opposite or adjacent.
Yeah, they're the legs, but they could be opposite and adjacent. Now, all I want you to take away from that is we're using the letters A, B, and C. You're not going to be thinking about the terms opposite and adjacent and hypotenuse. Not in this lesson at all. We're just going to use A, B, and C for the sides. Now, we have a Greek letter that we use for the angle across from side A. Anyone remember the Greek letter that goes across from A? Alpha. And the Greek letter that goes across from B? Yep.
Beta.
Beta. And last time we did this, that's all you needed. You didn't need a name for the angle across from C because C was always your hypotenuse, which means the angle across from it was always 90. Well, now I have to give a name to that angle because it's not 90 anymore. And that's gamma. So you still use the letters A, B, C. Always put A across from alpha, put B across from beta, and C across from gamma. Your drawing doesn't have to be to scale. But the relationship of where you put each side in relationship to each angle, that's important. Okay. So if you're doing a problem and you want to draw your triangle this way, that's fine. If you put A here, put alpha there. If you want to put B here, fine. Put beta there. See? Gamma. You could use either, any way you want to rotate, flip, or draw your triangle. Just make sure the relationships I just said are always true. Okay, so one type of problem that we're going to use the law of sines for is if I give you two angles and a side to start the problem off. Two angles and a side. I'll show you what it could look like. First one I'm going to do is ASA. Say angle, side, angle. That triangle on the left is an example of ASA. They've given you two angles, they've given you a side, but the side that they gave you is the one that's between the two angles. Look at the picture. 12 is the side that connects the angles. Okay? That's why it's called ASA. The other one, SAA, is the same information, but the side that they give you is in a different spot. So SAA would look like this. Let's say they gave me a side 8, an angle, and an angle. Still two angles and a side. Two angles and a side. But the difference in this one is where the side is. This time the side is not the one between the two angles. It doesn't connect them. If I had given you the bottom here, then it would be ASA. But if I gave you this one, which I did, or I gave you this one, it's SA. So any question on that? So either one of these cases, once we learn it, you're going to use law of sines to solve for everything else. The third case, and the last case, that we can use law of sines for is if they give you two sides and an angle. But it has to be set up like this. Say side, side, angle. You know two sides and you know an angle, but it's very important that it's not the angle between the two sides. That would be SAS. If I gave you this angle right here, you can't do that problem with what I'm teaching you today. So if they give you two sides and an angle, it has to be the angle that's not where the sides meet. So the goal is pretty much to try one of each. Now, as far as these abbreviations, sometimes you see them written like in the other order. Like this one, you can write AAS. It's the same thing. If you write SAA or AAS, I mean, if you want to even get crazy, you can take the first one and write it backwards. And you get that. Now, you could take this one and write it backwards. I'm not going to write that. So just leave that one in the order that it is. SSA. It's nicer that way. So we'll leave it like that. All right, but those are the three types of problems we can use this law that I'm about to teach you. That's what I just said. There are two more types. We're not going to learn them until next academic week. SAS and SSS. If you have one of those, you cannot use anything that I'm teaching you today for. Won't work. But on the test, I'm going to make sure that everything I give you is one of these three. So, we're going to take a look at kind of where the law of sines comes from. A little bit of it, not really the whole thing, but enough of it that I think it'll make sense. And then after we look at where it comes from, then we're going to use it to solve three problems. And then that'll be it. All right, so to kind of show you where it comes from, It actually is based on something that we already have done, right triangle trick, like the opposite, adjacent, and hypotenuse. Now, listen, if you look at the triangle that I have up there right now, that's not a right triangle. Bless you. Right? Just it's a scalene triangle, 3 random sides. No angles are marked as 90, even if they look 90. Unless it's marked as a 90, it's not a 90. Okay. So what I'm going to do is I'm going to take that triangle and I'm going to draw, well, first I'm going to label a couple sides and then I'm going to draw something. Let's call that A. And let's call that alpha. I'm going to call that B. And what would this angle in the lower right be? Beta. I don't need C for what I'm about to do. So I'm not going to label more than I need. I don't need C and I don't need gamma. So just label that. And then draw in that. Okay, I'm going to call that the height. And get a pen that writes. I'm just calling H for height, not hypotenuse. So it's height. And that's a 90. And that's a 90. Okay. Any questions on that picture? What I'm going to do now is I'm going to block the right side. I just want to focus on the left triangle for a second. Just that one. All right. So I want to come up with a formula to solve for the height of this triangle. And I want to use stuff I already know. That's the angle I want to use. That's the height. And that's the side I want to use. What's the name of the side that's we've labeled H from the perspective of alpha? It's the what side? So think about using your terms from a right triangle. Yeah, Chris used them earlier. Yep. You're using the right terms, but H is not adjacent. Adjacent means it's right next to you. H is farthest away as you can get from alpha. So it's opposite. So we've got opposite. And what about side B? What's that in my triangle? It's hypotenuse. So we're looking for a trig function that involves opposite and hypotenuse. What trig function involves those two sides? Opposite and hypotenuse. Sine. Yeah. So let's set it up. So the sine of alpha equals, and Nikara, what's my opposite? Yep, and what's my hypotenuse? B. So I have H, it's H over B. And Brandon, how would I get H by itself?
H by
Multiply by B. So H equals B sine alpha. That's a formula to find the height of the triangle. As long as you know B and you know alpha. And I'm going to call that box 1. Call box 1. Now, I want to do the same thing again. I'm going to block, this time I'm going to block the left triangle. Okay. I'm going to look at it from that perspective. Okay. So I want to find the height. I want to use that, and that. Caleb, now from the perspective of beta, H is what side? Opposite. And what about A? It's hypotenuse because it's across from the 90. So we have opposite and hypotenuse again. So it's the same trig function we just used. Sine. So sine of beta would equal what over what? Yep. H over A. And how about, Kaya, how would I get H by itself here? Yep. You're going to multiply both sides by A, just like we did before. So A sine beta equals the height. I'm going to call that box 2. Now let's uncover both sides. What do you know about box 1 and box 2? Why are they equal?
They both equal height.
They both equal the height. Box 1 is a formula for the height, box 2 is a formula for the same height. So that means the formula in box 1 really equals the formula in box 2. Once you write that down, that's basically the law of sines. So we've got B sine alpha equals A sine beta. Now, what they usually do with law of sines is they like to put the A over with the alpha and the B over with the beta. So how would you move let's move the A over to the other side. Divide by A. And how would you move the B over to the other side? Divide by B. So what you're left with is sine of alpha over A equals sine of beta over B. That's a proportion. And that's most of the law of sines. There's one more fraction you can add onto the end of it, which we're not going to go through again. But I think if you can see the pattern there, you can probably guess what the last fraction would be. So that's the first two parts of the law of sines. Sine of alpha over A equals sine beta over B. Anyone have a guess what the third fraction is? Without going through the proof, we could do it again just like we did. But I don't think we'll need to, yeah? Yep, sine gamma over C. So the law of sines has 3 fractions to it. You never use all 3 at the same time. When you're solving when you're solving for something in a problem, you're either going to use the first 2 parts that have the A and the B, the last 2 parts, the B and the C, or the first part and the last part, the A and the C. Right. Now, even though we're still using that law, keep in mind all the angles still add up to 180, so that's still true. But what you can't use anymore is Pythagorean Theorem. If you use Pythagorean Theorem, you're assuming your angle is 90. Now, if I give you a problem where it is 90, go for it. But if you don't know that you have a 90-degree angle, you can't use it. Okay, so that's the law of sines. Any question on that law? Let's see if we can get through 3 examples. Okay. So the first example says solve a triangle. Solve means you tell me everything that I didn't tell you. So how many things do you have to find here by the time you're all done? Chris? 3, yeah. So what we're going to do is we're going to go like this. A, B, C, alpha, beta, gamma. We're making a table to organize all the stuff we were given. We know A. Put a box around B because you don't know it. Put a box around C, you don't know it. Alpha is 20. Beta is 60. Gamma we don't know. Now, you're not going to have to worry about this as much for this test. But eventually, once I teach you the law of cosines, you're going to have to figure out, did he give me a problem with law of sines or law of cosines? Which law should I use? They're not interchangeable. You can't just pick which one you want. So the way you tell which one this is draw it. Go back to your notes and see, is it one of the 3 types that I told you? So we've got A across from alpha, B across from beta, C across from gamma. So, and actually we know beta, sorry, beta is 60. What kind of triangle is that if you wanted to describe it with the 3 letters?
SAA or side angle.
Yeah. Side, angle, angle. You know a side, you know 2 angles. The side that you know is not the one connecting the angles. That would be side C. So angle, angle, side. If you go back in your notes and look, angle, angle, side is definitely one of the 3 that you should use law of sines for. Okay, so now another thing you might notice there is you have a full row. If you make this table and you have something and what's across from it in the row, it's also a way to tell that it's law of sines. Think about if I gave you side, 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 you wouldn't have a full row. You'd have a full column. That doesn't work. So if you look at your table and you have a full row when you make it, then you know it's law of sines. Or you can make the sketch. Okay, what can we find first here right away? Without, you wouldn't even really need anything I've taught you today so far. Yeah, Emily? Okay, you could go for B right away. I'm going to say that that's going to take longer than something else, though. But what I think you can find first is fast. It's very fast. Yep. Gamma. Yeah, we can get gamma quickly because all the angles have to add up to 180. So gamma is 100. Now, when we did these kind of problems before, what did I say about using something that you found to find something else? Like you calculated something and then you use it to do something else. What did I say about doing that?
Try to avoid it.
Yeah, try to avoid it, because if you found something wrong and you use it, then you're going to get other things wrong. Well, with the problems we're doing this week, you can't always avoid that. You're going to have to use gamma to find C. So if you got gamma wrong, then C is wrong too. There's no way around it. But if you get gamma wrong, you could still get B right. Gamma has nothing to do with B, which is why I said you could have found B first. But it's going to take a little longer than gamma. Okay, so let's set up our proportion to find B. At this point, you have a choice. You can do B or you can do C. It doesn't matter which one you pick. So always start with a row that has everything in it. So we're definitely going to want to use row A. So what we're going to do is take your law of sines and fill in this part right here. Sine of alpha over A. Sine of 20 over 4. Equals. And now if you're finding B, use the part of your law of sines that has B. Sine beta over B. So sine 60 over B. We don't know. Okay. If you've set up your proportion correctly, 3 out of 4 of your parts in your fractions will be numbers, and one of them will be a letter. So I think I might have mentioned it earlier, but when you have a proportion, how do you always solve something like that? Yeah. You cross multiply. Yep. So we're going to do 4 sine 60 equals B sine 20. And now, what would be my last step to get B by itself? Well, Brandon, what was my last step? Yeah.
Sine.
Yes, perfect. You're going to divide by sine 20. Don't worry about what the sine of 20 is. We're just going to type it in the end. And divide by sine 20. And there's your answer for B. Okay. So we'll just type it in and see what we get. All of these law of sines problems in the homework and on the test are in degrees. So make sure you're in degrees. 4 sine 60. Very important, you close the parenthesis right there. If you don't, you'll get it wrong. And then divide by sine 20. So when you type it in, you should get 10.128. We're going to go to three decimal places on this. So 10.128. Okay, now we have 2 out of 3 of the sides. Could I use Pythagorean Theorem to get C?
No.
Why?
It's not a right.
Yeah, this is not a right triangle. If you use Pythagorean Theorem, you're assuming that's a 90, but it's not. So it won't come out right. So now you're going to find C. Same way you just found B. Set up a proportion. And you're free to pick any row that has everything in it to start. How many rows do I have that have everything in it here?
2.
2. Which row should I pick?
A.
Yeah, we should go with row A because first of all it was given. Second of all, there's no decimals. So sine 20 over 4, just like we did the first time. And how about Eric? What's going to go on the right side to find C?
Fine. Sine 60.
Well, sine 60 would be if we were solving for B. We would use sine 60.
Oh, just sine it back.
What angle do we use to find C? Yep,
Sine 100.
we use gamma. So sine 100 over C. Now, I'm going to do the cross multiplying all in one step this time. If you can do it like this on the test, that's fine too. It's going to be 4 times sine 100. And then you would have equals C sine 20, but you'd have to divide by sine 20. So I did what I just did in the first one, but I did it all in one step. So 4 sine 100 divided by sine 20. Type that in, and then that's it. So sine 20. Again, notice how I close the parenthesis. If you don't, it's going to mess you up. 11.518. Okay, quick thing you can check is the biggest side should go across from the biggest angle. Smallest side should be with the smallest angle. If that doesn't happen, then you did something wrong. Okay. Any questions on that type? Next type is very similar. This time you can tell, because of the diagram, what type it is. A, S, A. Angle, side angle. So this is law of sines, just like the last one. Other thing to mention to you on a test, this would be 3 questions. I would count each answer as its own part. So since these law of sines problems take a lot more work, each answer is going to count as its own question. Okay, so same thing here. You've got three questions you're solving for. So 3 sides, 3 angles. Okay. Do I know side A? Kira? No. Emily, do I know side B? No. Brianna, do I know side C? Yep, what is it? 4. It's not labeled C, but it's across from gamma. That's how you know. Chris, do I know alpha?
Wait, yeah.
What is it?
40.
One more time. 45. Beta is 40. And gamma, we don't know. Now, I said to you earlier that you know that a problem is law of sines if you have a row that's full. Well, is there a row that's full right now? No, right. There isn't a row that's full, but you can easily get one that's full, and then you're good. What would gamma come out to? Yep. 95. Now, getting gamma right this time is even more important than the first angle last time, because you are going to use gamma to find everything. This is the only full row you have. So you're going to use this row to find A. You're going to use this row to find B. So pretty much what that means is if you get gamma wrong, it's all wrong. So you got to be very careful on this one. All right. Jerry, could you set up my proportion to find A?
Would be sine of 95 over 4 is equal to sine of 45 over A.
Yep. And if you're wondering, does it matter which side you put on what? No. You could put sine 95 over 4 on the left, or you could put it on the right. It doesn't make a difference. Okay. Can somebody else tell me what A will equal? You don't need to give me a decimal, just what times what divided by what. Oh, Sam, could you tell me what my fraction would be for A? Yeah, when you cross multiply and then get A by itself before you plug it into a calculator.
We'll put A sine 95 over 4 sine 45.
So when you cross multiply, you have 4 sine 45 equals A sine 95, right? Equals. And then what about once you get A by itself? Well, let's do it in 2 steps. So go ahead and tell me what you said the first time.
A sine 95.
So A sine 95.
And then 4 sine 45.
And what about right here? Yep. And now how would you get A by itself?
You divide by sine 95.
Yeah, exactly. So you'd have 4 sine 45 over sine 95. And that's your A. Yep, good job. So let's see what we get. 4 sine 45 divided by sine 95. So we get 2.839. Right, and let's set up our proportion to find B. So Jacob, what would I put on the left side to set this up to find B?
Sine 95 over 4.
Yeah, we're going to use the same row that we did the first time because we know it's right. Well, we had to find 95, but at least we know it's nice numbers. Sine 95 over 4 equals. And Nikara, how about on the right side?
Sine 40 over 2.
Yep. And now let's do the cross multiplying, and I'll leave typing it into the calculator for you. If I cross multiply and get B by itself, what would B equal here? Emily? Yep. 4 sine 40 over sine 95. type that in, and then you'll have your answer for B, and you're done. So that's the second type. That's angle, side, angle. Both of those cases gave you two angles and two angles to start with. This case is a little different. They're giving you two sides to start with. So, three things can happen when they give you two sides to start with. One thing that can happen is you start to go through the problem and it's just like the last ones. Just normal problem. The other thing that can happen is you start to solve it and you realize that it's not a normal problem and that everything you're solving for has two answers. And it has to do with the ASTC chart. That's where the second answer would come from. Or you start to solve it and you realize, wait a minute, there's no answers to this problem at all. He gave me a problem that you can't do. So today, we're going to focus on the one answer case. Now, as we go through it, I'll show you how you find the second answer, because that's important. But then I'm going to show you why it doesn't work in the problem we're about to do. Sometimes it works, sometimes it doesn't. Depends on the problem. Okay, so here's our last one. Same numbers you just wrote down. A is 3, B is 2, alpha is 4. Okay, what can't you do in this problem right away that you were able to do in the last two problems? Yeah, Brianna? Right, you can't solve for an angle right away because you're missing two of them. So we're going to have to solve for an angle later. Now, this problem also has a very specific order you have to find things in first. You have to find beta first. C and gamma, right now, are useless. You can't use this row to do anything because you're missing everything in the row. If you have a row that's totally empty, it doesn't offer you any help at all. So you have to stick with the rows that have information in them. Okay? Now, once you get beta, then you'll have 2 out of 3 of the angles, which would allow you to find what? Gamma. And then once you have gamma, you finally have a piece of information in the last row that you can use to find C. Okay, so that's the order you're going to have to find these things in. So let's start with beta. So Chris, for my proportion to find beta, what can I put on the left side?
Beta?
Yes.
Sine 2.
Think back to your formula. Do you remember what always goes in the top of the fraction? There's something you can always write in the top of the fraction.
Sine 40.
Yeah, you can always put sine, no matter what the problem is. Just start with sine. Sine 40 divided by 3. You got to keep the fractions with the same row. So sine 40 over 3 equals, Kaya, what would go on the right side? You want to help her out? What would we put on the right side? remember what we're solving for. So that limits you to what row you have to use. Yep. Sine beta over 2. Now, cross multiply, just like you always do. In fact, really, you don't even need to cross multiply. Just multiply both sides by 2. And that gets sine beta by itself. Now, remember, the goal here is to find beta. I don't want to know sine beta. So how do I get rid of... Yeah.
Inverse sine.
Inverse sine. Take the inverse sine of what's on the right. Take the inverse sine of what's on the left. So let's type in inverse sine of 2 sine 40 over 3. Don't try to cancel anything. Just type it in just the way you see it. 2 sine 40, close your parenthesis, divide by 3. Now, unless you type something in wrong, that isn't a no solution problem because I just got a solution on the screen. 25.374.
Another way you can type it.
Yeah, I don't think that'll work on this one.
Oh.
It might not because you have a little bit newer one, but yes, you can do that on yours. So 25.374 is definitely correct. What you want to do, though, is put that answer up a little higher in the box because I'm leaving room just in case there is a second one, and I'll write it down below. Now, the way the second answer works is it's all or nothing. You don't have to worry about the ones that were given to you. Those are done. You have to worry about beta, gamma, and c. And the way it's going to work is they either all have one solution, they all have 2 solutions, or they all have no solution. Okay? That's how it always works. So we know it's not no solution because I just got 25.374. So it's either they all have 1 or they all have 2. All right. So think about your diagram. When we deal with a triangle, what's the largest that the angle could ever be in a triangle? Yep. Less than 180, like 179.9 or something, right? That's the biggest it could ever be. So the only answers that you could ever get are in those 2 quadrants. You just got an answer in quadrant 1, 25.374. How would you get the other answer based off this, which is your reference angle? Yeah?
180 minus.
Yeah. So to check for the second answer, do 180 minus 25.374. So 154.626. Don't put it in the box yet. So that is the second answer, if it works. And the reason I say if it works is because in a triangle, there's a certain rule about the angles. What's the rule about all the angles in a triangle? Yeah?
They have to add up to 180.
They have to add up to 180. You were given this one. There's no question about that. Could you fit the angle they gave you with what you think the second answer is? No. In this time, the second answer is too big. That would add up to 194. So for this problem, you don't need the second answer. You're not going to have to worry about a second answer for anything. Okay? Now, if you had subtracted from 180, and let's say you got an answer of like, I don't know, 110, then I would say, yeah, that works. 40 and 110 doesn't add up to more than 180. So then you would write down 110, and you'd have 2 answers for everything. Okay, but you're only going to have to worry about the one answer. I might ask you what the second answer is, and you can just cross it out and show me it doesn't work. Okay. Eventually, we'll do some where it does. Okay. Now that you've got beta, all we have to do is add these up, 65.374, and subtract from 180. So that makes gamma 114.626. Now you've got a piece of information in the last row, So now you can find C. So I'll just set up the, we'll just set up the proportion to find C, and I'll leave typing it in on the calculator to you. C. Okay. What can I put on the left-hand side of my proportion to find C? Yep. Yeah, we're going to go back to the row we started with. We're going to use that row for everything. Good job. Problem is we didn't know the angle across from C, but now we do. Sine 114 over C. 114.626. Okay. Cross multiply, and there's your answer for C. Just type that in and see what you get. So the key that some people get messed up with, probably not you guys as much because we've been doing the ASTC chart, is how do you get the second answer? Well, you guys, we've been doing that all week. So when I show this in like intro to trig, they never have seen the ASTC chart. So it's the first time they've ever subtracted from 180. But if you need it, I'll put it in the video, but you guys should already know this. To check if there's a second answer, it's 180 minus your reference angle. And you already have that in your ASTC chart. And then, once you get that, see if it's possible to fit the answer you just got and the one they gave you in the same triangle. And by fit, I mean it has to add up to less than 180. If it's more than 180, the second answer doesn't work. Okay. So that's the law of sines. Okay, looking at the first two cases and the third case, but only the one solution. Only the one solution. Okay, so homework, it's on 435, except for these two problems I wrote right here. So it's 5 through 8, 10, and 16. And then these, this is a problem. Call this bonus problem 1, bonus problem 2. Okay, so I'll check that tomorrow. Don't forget, I will be after school today if you need extra help. If there's any test you got to finish up, unless you've talked to me, any tests from before, any tests from last academic week, they've got to be done by tomorrow. Unless you talk to me for some other reason. Question, Jerry?
I was asking if that was alpha, but I saw the degree.
That's an alpha, yeah. Alpha, beta, C. Each one.